This is for year 12 further maths, and we're looking at exercise 8D, question 11. Now I've got a scenario where we have a new car. It's valued at 35,400 at the start of the year, and then at the end of the year it's valued at 25,700. Now during the year the car traveled this long. Okay, so this is actually unit cost depreciation. Okay, so we're trying to work out the cost per unit of and I'll explain what that means later. We'll just let's work out what part A is. Find the depreciation cost of the car in dollars. Okay, so depreciation of the car in dollars is basically how much has it lost in 1 year, or in the time frame given, which is 1 year. So simply the new cost minus the current cost, which should give you 9700. Put a dollar sign there. Find the depreciation per kilometer. Okay, so it's lost this per year, or for that year, and the car had traveled 25,000 kilometers. So to find the unit cost, like how much does it actually cost per kilometer, this is per year, that's traveled 25,000 kilometers. So per 25,000 kilometers, all you need to do is you need to divide 9,700 divided by 25,000 to get the cost per kilometer, because what you have at the top, you have the cost, and down the bottom how many kilometers you travel. So it's cost per kilometers. Does that make sense? So that's why you have to divide that by that, and you should get on your CAS calculator 0.388. Okay, and it's in dollars. Okay, because why is it in dollars? Because the top units are in dollars, so it's dollars per kilometer, if that makes sense. Now I prefer to leave this in 3 decimal places only because this is like a rate. Okay, it's a rate, whereas something like this is a dollar amount. Okay, this is also a dollar amount, but it's dollar amount per kilometer, so it's a rate. So I'm trying to, unless it specifies to put 2 decimal places, I would put it to 3 or leave it as the 4 decimal places just for now. So using the rule V0 equals that, so that's obviously the new value of the car, the principal value. Write down the rule for the value of the car. So the rule, we're not after recurrence relation, rule Vn after n kilometers have traveled. Okay, so we know Vn is given by the value of a new car, 35400, minus you minusing $0.388 every kilometer you travel. So that's why it's minus 0.388n. If you don't know what I've done, I've just followed the rule in the formula sheet. Vn is given by V0 minus Dn. Okay, V0 is your starting value, or your principal value, which is the new car price. D is my depreciation amount per unit, okay, which is 0.388, and you're subtracting because you're depreciating, and N is obviously just, represents how many kilometers you traveled. Okay, so how many kilometers I've traveled when the value of the car is 6688? Very simple. All I'm doing is I'm using this formula, but I'm subbing in 6688 for Vn. Okay, so when I sub in 6688 for Vn, I get left with 35400 minus 0.388 n. All I'm doing here is, so I've substituted for Vn this value. I'm just trying to solve for how many kilometers, because n represents the number of kilometers traveled, to reach a value for my car value to reach 6688. So I'll use a CAS calculator to help me solve this, because and further, we're not expected to know how to do algebra. You just need to know how to set up the equation. Okay, so what I do expect you to do is know how to set up the equation. Okay? It takes practice, but it's not impossible. So, and instead of n, I'll just use the x here. The reason being, it's easier to it's more accessible. So you type in the equation as is, highlight, interactive, advanced, solve. Okay, great. 74,000 kilometers. So n equals 74,000 km. So make sure you put units in. Okay, I'm not gonna. If you don't put units in, you're not gonna get the marks. Okay. So next part, including the first year of travel, how many kilometers is the car expected to drive before the value is 0? So this is actually telling us we want the value of the car to be 0. So remember, Vn represents the value at any after x, after n kilometers traveled. So we want that value to be 0. So we're subbing in 0 for Vn, and we're trying to find out what value of n does that occur. Okay. So how many kilometers will occur? So all you need to do is go to your CAS calculator again. Oops. And we're going to solve this equation. So we're going to go 0 equals 35400 minus 0.388 x interactive advanced solve, and we can see how many kilometers is expected to reach 0. Now, you got to be careful with decimal places here, because we're talking about kilometers. It says how many kilometers, it doesn't say how many decimal kilometers. So if it's above a decimal point, you just round up one. Okay, you automatically round up one. So it's 91238 kilometers. 91238. So 91238 kilometers. So it takes that long for the value of the equal to equal 0. Now, you do need to use interactive and solve, because if you do it in sequences, that's a very, very large number. Okay, and you're not going to have the time to scroll down to that number. So this is why this is preferred. So that's basically how you do a depreciation question. So a simple flat rate depreciation, unit cost depreciation question in the textbook. Hopefully that helps.